The reality is that people spend so much time trying to fix bugs like this, so there's gotta be a better way, right? In this video, I'm gonna be sharing some common challenges that I see with iterators. In some of my recent videos, I've been talking about iterators, enumerables, and different collection types. And specifically, I've been sharing with you that historically, I used to really like to lean on enumerables and iterators because I like the streaming approach that they provide. However, due to a lot of challenges that I've seen working in teams where people aren't really familiar with iterators, and this includes myself because I get caught up on some issues, I've been moving to a paging approach instead. Before getting into some of these challenges, it might be helpful to do a recap on the previous video that I did, which talked about iterators, enumerables, and some API designs that you might want to consider. So you can check that out right here and then come right back to watch this one. Also, a quick reminder to check the pinned comment to a link to subscribe to my free weekly software engineering newsletter. All right, let's go to Visual Studio to check out some code that's really going to demonstrate why there's some problems with this stuff. All right, on my screen, I have a simple program that we're going to be looking at, and it's going to start with dealing with a repository pattern. So as you can see at the top here, I'm just creating a new repository, and then all we're going to do is ask the repository for data and print that data out to the command line. Now let's have a look at what this repository does. So you can see inside here that I am creating a new connection factory, and I'm using some funny classes here, so we'll look at these in just a moment, but these are just dummy classes to demonstrate how some of this connection stuff works behind the scenes without actually having to go out to a whole database to show you how this stuff works. On line 42, we can see that I have a getData method. It is an IEnumerable that's going to return this data record that I've created. If we have a quick look at that data record, it's really simple. It just has a integer value, and it's not really important. I just wanted to have a custom type to show you. And I'm going to have some console write lines that we're going to be looking at because they're going to tell a story for how this data is accessed. So what we end up doing in here is that we try to write to the console, and then we're going to open up a new connection, read that data, and then we have a finally block here where we write to the console that we're done getting the data. There's a bit of foreshadowing here because you can see that I have a little fix commented out. So yes, there are bugs in this code that's on the screen currently. We're going to try to fix them and then talk about some of the challenges that come with those fixes. So we should check out what read data does. So if I go into this, we can see that I'm going to change the console color. Again, this is just going to help demonstrate when we're looking at the output that we want to call out when we're truly trying to do some access with this connection. And the reason I want to call this out is because that's where some of the problems are going to occur when we're working with this example. So I'm going to have the console as read when we are using the connection and we're trying to read the data from that connection. I've left a comment here because you can see that I'm just yielding out these records, and that's because I'm not truly using anything like Dapper, Entity Framework, or even creating a data reader to a SQL database. This is all dummy stuff for now, but I'm just simulating how this works. If you recall from the earlier videos or just your own experience, because we have this yield return here, plus this IEnumerable, that means that this entire method is what's called an iterator. And that's extremely important for this conversation because, as I've been mentioning in the earlier videos, IEnumerable can be an iterator if you're looking at the implementation and you see yield return, or it could be backed by a materialized collection. When it's an iterator, it has lazy behavior, and when it's backed by a materialized collection, that's like an eager approach and it's not lazy. So if we unwind this call stack from read data, we go back up, we can see that getData is calling read data after we've opened the connection. We're going to return the result from read data all the way back up to the top here, right here on line 2, and then from there we print that stuff out to the console. So far so good, right? Well, let's go run this and see what happens. All right, the story that we see being printed out to the console is that we're starting that getData method. We end up opening a new connection, we exit getData, and then from there we start the iterator that is inside read data. We can see that we're getting data 1, 2, and 3. So that's coming from the top part of the program. And then we have ending iterator inside read data. All of that is red because we toggle the console going red inside the beginning of read data, and then we put it back to normal at the end of read data. So it might not be obvious what's wrong with this, but it's a subtle detail. And that's that we're not disposing our connection. When the connection gets disposed, we end up printing to the console that we are disposing that connection. And I didn't show you that because I didn't want to give away the little surprise here, but that's the bug that we're going to be fixing. And you might have even noticed that by looking at the code I was showing you, because there was no using statement when we're dealing with the connection. So you can see that we open the connection here, but what we probably want to see is at the end of all of this that we're closing off the connection in some capacity. But that's super easy to fix, so let's go back to the code and make sure that we put a using statement where it's needed. All right, so line 47 here is the spot that we don't have a using statement. Now I just want to show you two different variations that you can use a using statement. So the traditional way that we can use a using statement is to wrap it around the part that we want to use, like this. So this is the connection that we're going to be using. And then we have the curly braces that we're explicitly saying we want to have the lifetime for. This is one way that we could go address this, but the other way is this new format, and it's kind of nice, but it's kind of spooky for people that are used to having the curly braces. And if we go to a simple using statement, what we can see here is there's no more parentheses around this code and there's no more curly braces here. But what this is able to do is when connection goes out of scope here, just like it would have with the other curly braces, we will get the dispose called implicitly at the right location. So this syntax that you see right here is very similar to what I had with the curly braces explicitly provided. So in theory, this should go dispose of our connection. And if I scroll back up just to show you, pretend connection, when it's disposed, will say connection is disposing. So now we have a proper using statement. Let's go run this and see how it fixed it. And awesome, as we can see on the screen, we have connection is disposing. That's great, it means the using statement's working. But wait a second, we're opening a connection, and then the very next thing we see is connection is disposing. Then we're ending get data, and then we're trying to read the data from that connection. So wait a minute, that's not going to work. We can't possibly dispose the connection up here and then try to read from it later on. That's going to throw an exception because the connection's not available. Quick pause, because for some of you that might have been very obvious. You might have expected that this behavior was going to happen because you've dealt with iterators before. But for a lot of people that are watching this, and it's not your fault, if you're not sure why that's breaking, I'm going to show you how to fix it, why it's happening, but I don't think it's obvious to a lot of people until you've dealt with iterators and you're used to how they function. And how they function is that they are a function. They're a function pointer. And that function is not evaluated until you go evaluate the iterator. Let's head back and see how we can fix this. And just to be clear, the issue is not that we don't have the curly braces in here, I can assure you. And what we're going to do is put this fix in right here that I left for us. And I'm leaving in the broken code so that you can see what we used to have and how this is going to fix the issue. What's going on as a solution here is that we're explicitly yield returning each individual item that comes out of read data. We are trying to evaluate the iterator and then turning this method now into an iterator. The difference in how this behaves is that it used to just return a function. This read data was an iterator, and then we're just passing read data as an iterator, or a function, right back up through get data as the return type. That means that this method used to complete nearly instantaneously, and that's why the using statement was closing off and disposing the connection right away. Now what's going to happen is that when we open up the connection, we're going to go into read data, and then when it goes to yield return, what it will do is surrender control back up the call stack to be able to provide this data, and that means that we're going to be stuck inside of this for each loop. As we're stuck in here, that means that this using statement is not going to end up disposing the connection because the connection's still in scope. We haven't left the method truly. On the next iteration of the loop, the same thing's going to happen where when we go to yield return this back up, we're still stuck inside the loop technically. And the same thing with the third iteration of this loop, because there's 3 items inside that read data. But finally what will happen is once that third item has been yield returned back out, we leave the for each loop, and finally this connection is going to go out of scope, so that means this using will then dispose of the connection. So all that we had to do, and it feels a little bit silly, but once you understand that read data was just returning a function pointer, and instead we need to go turn this entire method into an iterator to avoid that, this starts to make a little bit more sense. It's just a little bit clunky. Let's go run this and see how it fixed it. All right, we can see that we're opening a new connection, then starting the iterator, printing out each data item, and ending the iterator inside read data. Then after that, so once we have no more red text, we can see that the connection is then disposing. So truly, we had the connection open the entire time this text was read, and then the connection's disposing after. So this using statement is now executed properly because we turned that method into an iterator itself. We had to force iteration down lower in the call stack instead of just returning out that IEnumerable. So that's a really common crappy problem that I've seen with IEnumerable and iterators. Having resources held open and closed too soon and stuff like that is just really problematic, and it's not super obvious. The debugging that goes into that, if you're not totally sure how an iterator works, is a little bit mind-melting. But if you're working with someone that has experience with it, or you yourself have the experience and you just kind of slipped up, it's not so bad once you know some of the patterns. But I want to walk through one more kind of funny situation that I've seen with iterators, and especially when it comes to user interface-based applications. Let's head back to the code and I'll explain this one to you. All right, so I'm back in Visual Studio. We're going to leave the code just as it was with the repository changes we made because that using statement is now functioning properly. However, you can see that I've changed the code at the top here, and what we're going to do is make a very small layered application where we have the repository that comes from our data layer. This would be in the lowest layer of our application. Then we have a service that can reference that repository, and that service is where our business logic and application logic would exist. It's going to be sort of this middle layer that we'd have in a layered architecture. And then finally, this UI control is going to have access to the service. And if you're thinking about this, that means that the UI control doesn't have direct access to the repository, but it talks to the service, which then has access to the repository. But let's go see how these things work when we try to refresh the list contents in our imaginary UI application. All right, in the UI control, you can see that I am taking a reference to that service, just as I mentioned up above. And when we look at refresh list contents here, I'm not truly working with a UI application, so I'm going to print stuff out to the console again to simulate what's going on. This refresh list contents, if you're not familiar with a lot of UI architectures that exist, this kind of stuff needs to be able to execute on a main thread. So there's lots of separate learning to go do on that, but that's a pretty common pattern that you have a user interface thread that's going to do all the user interface painting for us. And when we go to work with controls and the user interface, this stuff gets done on that main thread. So I'm going to mention that we're entering this method, and that means we're on the main thread. And what we're going to do is try to get that data from the service, and then at the end, we're going to say that we're ending this method. But what does the service do? Well, let's go check out the getData implementation. It's pretty simple. It's just a straight pass through. I'm mentioning here that it's kind of nasty to be able to just pass this data DTO, this data transfer object, directly back up. Usually what you end up doing in a layered architecture is that if you have something like a data record that comes from the lowest layer, you might do some type of translation into a different type that gets passed up to the user interface. And that way you don't have things that are database specific that are going to be referenced all the way in the user interface. So the reason that this method looks super simple right now is because we're not doing any type of translation. We're not working between different domains and joining stuff together. We're simply just getting records and then passing them back up. So in this example, this looks a little bit silly because it doesn't do anything, but this is a similar structure to a lot of layered architectures. It's just that they're doing more work. And we've already seen what repository getData does, and we know that repository getData is working as we expect. So let's go run this and see what happens when we're looking at the user interface. All right, we can see that we're starting the refresh of the list contents on the UI thread. Then from there, we're getting data, and we have all of this similar stuff that we were just looking at. So the disposing is happening all correctly, and then we end the refresh of the list contents. This looks okay because we're getting the data that we expect right here that's highlighted, but the first line says we're already on the UI thread. And that would mean that if we're trying to get data from a database, we're technically blocking the UI thread with all of this code right here. And that means that we would get some type of ghosting, or the application would lock up. Even if it's very brief, we might notice something as a user because your cursor wouldn't be able to interact with the user interface that you're touching. And then at the end, we have this end refresh list content. So everything in between here is running on the UI thread, and that's definitely not something we want to do. So I'm going to show you what I generally see people try to do to fix this kind of thing, and we'll see what happens. All right, so the solution that everyone tries to go to is using async await. We're going to do this stuff on a background task, and that means we're going to get it all to work without blocking the user interface. So let's check out this silver bullet that we got going on here. We write to the console that we're doing this async method on the UI thread, just like the other one did, where we were entering refresh list contents. But then what's different is that we're calling all of this code on a task, and then we're going to await it. So I'm just adding extra console write lines to say that we're inside that task. We're going to get that data out, saying that we're ending that task, and then return it back up. So by the time we're finished awaiting this, that means that this variable for records is going to have all of the data that we want. Then from there, I'm just mentioning, hey, look, we should have got all that stuff done, right? So let's go print it out to the console and then end the method with a little marker that says that we're done. So just to mention again, what we're doing is putting all of that data access onto this task and running that before we go to do stuff on the UI thread. Back up on line 4, I'm just going to call await and then change it to be async for this new method that we've just added. And let's go see how this fixes things for us. All right, we can see that we're entering the method and then we have the task starting and then ending right away. But wait, we should have been able to get all that stuff done on the task though, right? But it looks like all of it's still happening afterwards. What the heck's going on? We put it all in a task. Why did it finish instantly? And the answer is lazy iterators. And that fix that we looked at before, where we were putting it in a for each loop and yielding it back up, isn't going to fix it for us this time. This is inherently broken the way that we've done it. What we need to do to be able to fix this one is materialize the data by calling toArray, toList, or otherwise forcing enumeration while we're still on that background thread. So while we're still in the task, we need to be able to say something like toArray, and that way we can get that done on the task, so hopefully on the background thread. Then from there, the UI thread will have a fully materialized array, list, or other type of collection that we can go use to refresh the list box or whatever control we're working with. But it's just not obvious for people. And I'm not trying to say that like I'm superior to other people, because this totally screws me up all the time. And I've been programming in C# for like almost half my entire life, and I'm getting kind of old now. The reality is that people spend so much time trying to fix bugs like this. So there's gotta be a better way, right? And this is primarily why I've moved to paging, because I've seen so many situations like this where people don't really understand how iterators work. It's really cool that they can be lazy evaluated, but you run into issues with resources being closed off too early or resources being closed off too late. In fact, the most recent thing that pushed me overboard to switch over to paging was that I was trying to get fancy with having a lazy loaded cached list of records, and I was holding stuff in an IEnumerable, which meant I ended up having database connections held open in a cache. And because of how it was designed, I held open all of these connections that were never going to get closed off unless someone fully enumerated the result set. I thought the design was super cool, but I totally didn't think about the fact that being an iterator, it wasn't going to close off that connection until I left that for each loop, just like I showed you in the code a little bit earlier. I had fixed the issue of the connection being closed off too early, but now it was only going to ever close off once everything was finally fully materialized. And if you never asked for the last value in that result set, it was going to stay open for forever. So without going back to the code to change it all to paging, because I don't want to waste your time just trying to walk through all of that, the big difference is that instead of putting IEnumerable and yield return and everything, what I do is change everything to be IReadOnly list instead. In some situations, IReadOnly collection might make sense. I like using IReadOnly list a lot of the time because the collections I'm usually returning back are arrays or lists anyway, and both of those already implement IReadOnly list. Some algorithms I write, if there's queues or stacks or some other type of collection that does not implement IReadOnly list, I will usually go to IReadOnly collection, and if I can't then I'm using IEnumerable. But IEnumerable doesn't work so well with paging, but having something like a collection that has the results fully available and having a count, that's really helpful with paging. So what we would be doing is, instead of saying, hey, just give me this result set and I will enumerate it when I'm ready, you're basically saying, going down the call stack to each layer, materialize this. So at the very bottom, instead of creating a lazy evaluated iterator, it goes, here's an array or here's a list. And you'll see it as an iRead-only list. And that means as you go back up the call stack, everyone's just getting that iRead-only list all the way back up. You still get a lot of great control, just like you would with a streaming API, because you can give it the page size and the offset. So you're controlling how many records you want to have come back up, and you're able to kind of shift where you're looking at in the result set. I had mentioned in earlier videos that doing some of the link things like any or first were really cool with iterators because you didn't have to get the whole result set. But if you wanted to do something like that, you could just ask for a single record by using a page size of 1 and then see if anything comes back. But another really big reason that I like moving over to paging is when it comes to the performance. There's been a lot of great enhancements in .NET recently, and depending on when you're watching this video, maybe those enhancements will show up with iterators as well, but at this time of recording, they're just not there yet. So you can check out this video next and see the performance difference. Thanks, and I'll see you next time.